Hello students, I am Dr. Salahuddin, working as Associate Professor in Noida Institute of Engineering and Technology, Pharmacy Institute, Greater Noida. In this lecture, I will discuss about the parameters used in the quantitative structure activity relationship. In the previous lecture, I have already discussed about the partition coefficient in the QSAR. In this lecture, I will discuss about the electronic parameters used in quantitative structure activity relationship, that is Hammet's electronic parameter. So, let us discuss about the electronic parameters. So, what is the electronic effects? The electronic effects of the various substituents will clearly have an effects on the drug ionization or polarity. So, the electronic effects of the substituents, that what we are doing in the quantitative structure activity relationship, basically we are substituting the molecule by various types of substituents. So, what is the role of these substituents in the ionization of the molecule or the polarity of the molecule, and how it affects the biological activity and may have an effects on how easily drug can pass through cell membrane, as the ionizability of the drug affects the passing of the cell membrane. So, it is also helpful in the cell membrane to pass how strongly and how easily, and it can binds also with the receptor. Now, this electronic effects in the QSAR we can discuss with the help of this Hammet substituent constant, and it is denoted with this sigma value. Sigma value, it measures the substituents on the aromatic ring, measure the substituents on the aromatic ring. At the aromatic ring, the various types of the substituents present and how it can affects the electronic parameters of the whole molecule, and it measures the electron withdrawing or electron donating of the substituents. So, here the substituents we are dividing into the electron withdrawing group and the electron donating group. As we know that electron withdrawing group decreases the electron density, and this electron donating group increases the electron density. So, here it will determine the measuring the dissociation of a series of substituted benzoic acid. So, here we are taking the benzoic acid as a reference as compared to the substitute benzoic acid. So, here the electronic effects of the compounds we can determine by measuring the dissociation of a series of the substituted benzoic acid compared to the dissociation of the benzoic acid itself. So, here benzoic acid is a weak acid. So, the dissociation of the benzoic acid is that the ionization of this benzoic acid partially, because this benzoic acid is a weak acid and only partially ionize in the water, and it will give this C6H5 COO minus plus H plus. So, after the ionization, the equilibrium is set up between this ionized benzoic acid and this non-ionized benzoic acid. So, the equilibrium between the ionized benzoic acid and the non-ionized benzoic acid, here we can observe that where the relative proportion of these species is known as the equilibrium or dissociation constant in terms of Kh. Now, here if x equals to h, so dissociation constant is dissociation constant of the ionized benzoic acid and the ratio of the ionized benzoic acid with the non ionized benzoic acid, so that we can observe the dissociation constant. Now, if X is the electron withdrawing group, this is the benzoic acid and here this is X group is present. So, if X is electron withdrawing group like alkyl group, phenyl group, so the aromatic ring is less able to stabilize this carboxylate ion. So, here the carboxylate and the ionization of the compounds, it is we can observe with the help of the substituents present, either it is the electron withdrawing group or the electron donating group. So, here we can have this sigma x values, it is calculated, this log k x upon k h, dissociation constant of the ionized and the non ionized, and by simplifying this log k x upon k h equals to log k x minus k h. So, here the equilibrium will shift to the left and a weaker acid is obtained with a smaller k x value. So, here we can observe the Hammet substituent constant like sigma by with the help of this formula. So, benzoic acid containing electron withdrawing substituents will have larger k x values than the benzoic acid itself. Benzoic acid itself, that is k h, that is on the substituted benzoic acid. Substituted benzoic acid and non substituted benzoic acid, the dissociation constant of the substituted benzoic acid is termed as k x and the non substituted benzoic acid itself, that is k h. So, here with the help of this example we can observe the electron withdrawing, will observe the electronic effects of the substituted benzoic acid. And substituted benzoic acid, it is substituted with the electron withdrawing group like chloro, CN or trifluoromethyl. So, the electron withdrawing group, it will ionize into C6H5COO minus, and here the electron withdrawing group is present. So, that the charge is stabilized by x, the equilibrium will shift to the right, that is k x is more than the k h. So, what is the why k x is more than k h? Dissociation constant of the substituted benzoic acid is more than the dissociation constant of the non substituted or the parent benzoic acid is less. So, the position of the equilibrium dependent on the substitution x. So, here the position also determines the equilibrium. So, here it is either it is present ortho, either it is present para or somewhere. So, sigma x equals to log k x upon k h equals to log k x minus log k h. In this case, the positive value will obtain. In the next case, when the benzoic acid have electron donating groups. So, in the benzoic acid containing electron donating groups, electron donating substituents. So, here in this case the dissociation constant of the benzoic acid is more as compared to the substituted benzoic acid here. So, log k x minus k log k h here, as I have already said that this substituted benzoic acid k x is less than the k h. So, that the value of sigma is negative value. So, benzoic acid containing electron withdrawing substituents will have a smaller k x value than the benzoic acid itself, and hence the value of sigma x for the electron donating substituents will be negative. So, here the Hammet substituent constant sigma, it is depends on both resonance and inductive effect, both resonance and inductive effects. It depends upon the type of the substituents present in the at the benzoic acid itself. So, how sometimes it will affect the both resonance and inductive effects, and sometimes resonance only. So, the value of the particular substituents will depends whether the substituents depends on whether the substituent is meta or para. Here in this case the charge is destabilized and equilibrium will shift to the left, that is k x is less than k h. Now, here there is one example, the very interesting example of the substituted benzoic acid substituted with the nitro, and here there are two substitution, meta substitution and the para substitution. At when it is meta substitute, meta derivative of the molecule, that is the meta substituted. So, electron withdrawing, that is electronic influence R is only and only inductive. If we change the R group, the position from meta to para, then the electron withdrawing, that it will produce the ionized compound as well as the resonating structure of this in this manner. So, that this electron withdrawing, the substituent is same, only the position is different. In first case it is present at meta, then it is only and only inductive. If it is present at para, so the electron withdrawing so that is inductive and resonance both. So, here what is the result in terms of the biological activity? So, ultimately it will also affects the biological activity of the molecule. So, that if the substituents present either the meta or this is para, so it will also affect the biological activity. Next, for the OH group sigma m, that is a sigma m, that is the OH group present at meta position and the value is 0.12, and if it is present at para position, the sigma value is minus 0.37. So, here the value also indicate that this sigma value, the presence of this OH group, either it is meta or para, it will affect the properties of the molecule. So, that the influence of this hydroxyl group on the meta or the para, it affects also the biological activity. So, here if it is present at meta and para, so if it is present at meta, only inductive effects, and if it is para, then resonating structure is more important. So, here electron donating by the resonance is more important than the effective effects. Now, here the question arises that how we can choose the exact substituents when we are doing the study. So, on the basis of our study, first we have to do the thorough literature review, how this group affects the biological activity in terms of the interactions with the receptor, or in another way like physicochemical parameters, like this physicochemical parameters is very important or not. So, with the help of the study, that we can choose the various types of the substituents, and accordingly we can develop a molecule, we can prepare the molecule to observe the quantitative structure activity relationship. Here we have the limitation. The Hammet substituent constant cannot be measured for ortho substituents, cannot be measured for ortho substituents, since substituents have an important steric as well as electronic effects. The very few drugs whose activities are solely influenced by the substituents electronic effects. Now, here the electronic effects of the compounds that we are observing in the with the help of an example. Here I am taking the one example, that is ester and ester. So, here a series of the aliphatic electronic substituent constant are available, so that we can change this value and it will produce the various types of the compounds and the different types of characteristics, and after that we can observe the measuring the rate of hydrolysis by a series of the aliphatic ester, like methyl methanoate is the parent ester, and it is found that the rate of hydrolysis is affected by the substituents X. So, here there is a one example, that is the insecticidal activity of diethyl phenyl phosphate is one of the few example where the activity is related to the electronic factor alone. So, by observing the electronic effects of this series of the diethyl phenyl phosphate. So, here the biological activity is the positive, related with the positive sigma. If so, here if the sigma value is positive, then the sigma value is positive means what? The electron withdrawing groups. So, in this study, if I am taking the insecticidal activity, we have to choose the positive sigma values. Positive sigma values means electron withdrawing groups, and this electron withdrawing groups increases the biological activity. Okay. So, here what is the result? The fact that the pi parameters is not significant is a good indication that the drug do not have to pass into the through a cell membrane or have the activity. That is, here there is no pi involved here, that means the only the effect of this electronic effect that is related with the sigma, and we have to choose only the positive sigma values of the substituents. Now, the problem here, how we can choose the sigma values. So, already there are various types of literatures are available that we can choose the sigma values on the basis of our requirement. So, the electronic effects sigma, R and F can only be used for aromatic substituents and are therefore only suitable to the drug containing aromatic ring. A series of aliphatic electronic substituents constant are available, obtaining by measuring the rate of hydrolysis for a series of aliphatic ester. So, here this is very important to calculate the hydrolysis of the ester with the compounds. So, that a series of aliphatic electronic substituents constant we have to prepare, and they are also available by obtaining the measuring the rate of hydrolysis for a series of aliphatic ester. For example, methyl methanoate is the parent ester, and it can be found that the rate of hydrolysis is affected by the substituents X. The substituent X means what? Substituents, either the substituents is electron withdrawing or the electron donating. So, that this electron withdrawing substituents or the electron donating substituents, it also affects the rate of hydrolysis of the aliphatic ester. So, here the rate of hydrolysis is affected is a measure of the substituents electronic effects at the site of the reaction, that is the ester group. So, here I am talking about the aliphatic ester. So, that the group, that is the hydrolysis of the ester is affected by the substituents. So, the electronic effects is purely inductive and the given sigma 1. And next thing is electron donating group reduce the rate of hydrolysis in case of aliphatic ester. Here, and the sigma values for the methyl is minus 0.04, C2H5 minus 0.07, propyl group, that is C3H7 is 0.36, and here the electron withdrawing group increases the rate of hydrolysis and have positive values, that is NCH3, Cn, NH3 plus also 0.93 and 0.53. So, what is the result by choosing the substituents, the type of the substituents here. So, the type of the substituents like electron donating group and the electron withdrawing groups here. So, the electron withdrawing groups increases the rate of hydrolysis. If our requirement is to increase the rate of hydrolysis, so we have to choose the positive value of the substituents, and if the rate of hydrolysis, then rate of hydrolysis is here electron will reduce the rate of hydrolysis, then CH3, C2H5, C3H7, that is the electron withdrawing group. So, electron withdrawing group and the electron donating group plays a very important role in the quantitative structure activity relationship, basically in the electronic parameters used in the QSAR. Now, here the inductive effects like we have already observed, that is inductive effects, and the inductive effects is not only the factor affecting the rate of hydrolysis, the substituents may also have the steric effects, Suppose if we choose a bulky substituents. So, the bulky substituents may shield the ester from the attack and the lower the rate of hydrolysis, therefore, necessary to separate out these two effects, and this can be done by measuring the hydrolysis, the rate of hydrolysis of the ester. So, the electron donating groups rate is decreases when the sigma 1 is negative. So, in case of electron withdrawing groups, the rate increases and the sigma 1 is positive. So, the choosing of the sigma is very important. So, and here the condition is also important, either the basic condition or the acidic condition. So, basic condition rate is affected by the steric and the electronic factors, and acidic conditions the rate is affected by the steric factor only, and this steric factor I will discuss in the next class. And now, here what is the I have discussed the role of the electronic effects in the QSAR. Thank you so much.